Welcome to this deep dive on the warehouse reality check. Right now, as you listen to this, I want you to just imagine standing on a highway overpass, looking down at all the semi-trucks rolling by beneath you.
Yeah, that's a lot of trucks.
Right. And according to this massive survey of, I think it was 158,000 trucks down in Georgia, 9 out of 10 of those trucks you're picturing right now are carrying mostly empty air.
Wow. 9 out of 10.
Yeah, 91% were severely underloaded. I mean, they're burning diesel, generating emissions, taking up space on the highway, and literally not carrying their weight.
They're essentially, ghost ships. And the craziest part about this is the companies paying for those trucks. They often look at their software, and they honestly believe those trailers are packed to the absolute brim.
Which is wild.
Yeah.
So today we're figuring out why that massive blind spot exists. We're basing this on a specific document we have, a source called maxloadandloadplanning.pdf.
Right, the case study.
Exactly, a case study about a $600 million consumer goods shipper. They realized they were just bleeding money through empty trailer space, so they launched this initiative called Project Maxload.
And they brought in technology from Provision A to fix it.
Yes, Provision A. We're to explore the chaos on the shipping dock, the total failure of modern load planning, and how fixing the gap between digital spreadsheets and, 3D physical reality is kind of the ultimate secret weapon.
It really is. I mean, optimizing every single truck's payload, that's the lever you pull when you want to protect your shipping capacity. It drastically lowers transportation costs and hits those aggressive sustainability targets all at the same time.
So it's a big deal for whoever's listening to this, whether you're dealing with scarce trucks or an abundance of them.
Definitely. You have to be willing to look at the really messy reality of how trucks actually get loaded.
And I want to start right there with that messy reality. Because, I mean, that 91% statistic just feels almost impossible to me.
It's hard to wrap your head around.
Right, because companies do not want to just throw money away. So if a load planner's entire job is efficiency, and they know a standard truck holds, say, 45,000 pounds, why on earth are so many trucks leaving the dock with thousands of pounds of empty capacity?
Well, it looks like sheer incompetence from the outside, but it actually stems from a fundamental flaw in how enterprise software views the real world.
Okay, let's unpack this. How so?
So modern supply chain tools, like your advanced planning systems, they are incredible at forecasting demand, right?
Right.
They can analyze all this historical data and say, you need exactly 50 pallets of shampoo in Chicago by next Tuesday.
So they handle the macro level math beautifully.
Exactly, they do. But they treat the actual physical reality of putting boxes into a metal box, the trailer, as an afterthought. The system basically plots a perfect route in this two-dimensional digital void. It completely ignores the physical constraints of the trailer itself.
Yeah.
So the planner looks at their screen. They see an arbitrary threshold, let's say 40,000 pounds.
Even though the truck can hold 45,000.
Right. And once the software hits that 40,000 number, they check the box. They consider the truck full. They leave this 5,000-pound buffer just because the software literally cannot calculate the actual geometry of the load.
Okay, it's like packing for a 2-week vacation in a giant suitcase, but you only throw in 3 T-shirts and a pair of socks because you never actually measured how much space you had. You're paying to check the whole suitcase, but using a fraction of it.
That is a perfect analogy, and it reminds me of using a GPS app that completely ignores real-world traffic or construction.
Oh yeah, just drawing a straight blue line through a mountain.
Exactly. The digital plan ignores the physical friction, and that friction is incredibly expensive. Leaving 5,000 pounds of capacity on the table for every single truck destroys your margins.
I can imagine. So, okay, the planner in the corporate office is relying on this flawed software threshold. But what about the dock worker? The person physically driving the forklift, looking at 10 feet of empty space at the back of the trailer.
Yeah, the guy on the front lines.
Why can't they just, eyeball it and throw another pallet in there, fill the gap, and save the company a trip?
Because if they fill that gap, it introduces an absolute nightmare of physics and legal liabilities.
Wait, really? Legal liability?
Oh, yeah. This brings us to the complexities of axle weight and regulations like the California Bridge Formula.
Oh, I saw that in the Max Load and Load Planning PDF, the Kingpin rule. I got to be honest, what does the Bridge Formula have to do with a forklift driver placing a pallet of soap?
Basically everything. Highway regulations don't just care about the total gross weight of a vehicle, they care intensely about how that weight is distributed across the axles.
Okay.
Because if you place too much heavy freight near the rear doors of the trailer, it acts like a giant seesaw.
Ah, I see.
Yeah, it amplifies the downward force on those specific rear axles.
So even if the truck only weighs 40,000 pounds overall, which is well under the 45,000 limit, if it's not balanced right, those rear wheels are just grinding into the asphalt with illegal force.
Exactly. The structural integrity of highway bridges relies on weight being evenly spread out. If a loader just tosses an extra heavy pallet into the back to fill space, they completely throw off the center of gravity.
And doing the calculus for that, like balancing 45,000 pounds over specific axles in your head while driving a forklift in a loud warehouse, I mean, that's impossible.
Totally impossible, especially when you've got a truck driver tapping his watch because he's running out of legal driving hours.
Wait, the pressure is on.
The dock workers are just trying to survive. They don't have time for complex physics equations.
Which creates this massive culture clash, doesn't it?
Sure.
I mean, we've got two totally different worlds colliding here.
Very much so.
On one side, you have the load planner. They're sitting in a quiet, air-conditioned corporate office, focusing on software metrics and cost per mile. And then the truck loader is on this sweltering dock, just trying to make the physical reality work.
Yeah, the planner creates this abstract dream, and the loader wrestles with the physical nightmare. And historically, these two groups, they rarely communicate.
The source material highlighted this wild detail about the $600 million shipper. It said some of the load planners had literally never even visited a production plant.
Not even once.
Right. They'd never stood on a dock, felt the heat, or watched a trailer get loaded. But they're dictating the whole process from a screen miles away.
Well, you know, when the architect never visits the construction site, the builders just start making up their own rules. In warehousing, we call that tribal knowledge.
Tribal knowledge. The case study noted that if you asked 10 different loaders how to load the exact same freight, you get 11 different ways to do it.
Exactly.
Like one guy says, double stack the heavy boxes. Another says, never put a mixed pallet past the 48-foot line. They aren't mathematically sound. They're just survival tactics.
And tribal knowledge thrives in an information vacuum. The loaders get a plan from the office that they know is impossible, or at least mathematically dangerous. So they basically toss the plan in the trash and load it based on their gut.
Okay, but if the loader realizes the plan is impossible and they just guess, what happens when their gut instinct is wrong? If they create an unbalanced load, what's the actual fallout?
It is an incredibly expensive logistical failure.
How bad are we talking?
Well, the truck leaves, drives to a state weigh station, and the scales detect the rear axles are overloaded. The highway patrol flags the truck, issues a hefty fine, and forces the driver to turn around.
Oh, man.
Yeah, the truck literally drives right back to the warehouse dock to be completely unloaded and reloaded from scratch.
The wasted time there is just staggering.
Yeah.
You're paying for the miles, the fine, doing the job twice, and your customer gets a late delivery.
And the worst part is there is no feedback loop.
What do you mean?
The planner in the office often never finds out why it came back. They just see a delayed shipment on their screen. So they keep making the same bad plans, and the loaders keep ignoring them. The system is just broken.
So this brings us to the breaking point for the company in our Project Max Load case study. They bring in Provision Eye to build this collaboration framework. But reading the source, the very first step they took, I kind of had to laugh.
Oh, the tape measures.
Yes. I mean, we are talking about highly sophisticated supply chains, right? Algorithms predicting global demand based on weather patterns. And you're telling me the bottleneck to saving millions of dollars was that nobody bothered to use a tape measure.
It really is the most humbling reality of supply chain management.
How does a $600 million company miss something so basic?
Well, you can't build smart software on top of bad physical data. The industry calls this master data decay.
Master data decay. So the system of the database telling the software how big the boxes are was just wrong.
Completely wrong. I mean, think about how often products change packaging. A company wants to use less plastic, so they make a shampoo bottle thinner. Or shrinkflation happens, right?
Less cereal in the same price box.
Exactly. The physical box changes on the line, but nobody bothers to update the dimensions in the enterprise software.
So the database thinks the box is 12 inches wide, but it's actually only 10.
And the software plans a truckload based on ghosts. It thinks the trailer is physically full because the outdated math says so. They realized before they could use any fancy AI, they had to establish ground truth.
Meaning they actually send people out onto the floor?
Yes. with literal scales and tape measures to weigh and measure every single item they shipped.
The ultimate garbage in, garbage out principle. They fixed the physical inputs first. So once they got the accurate data, how did the Provision A tech actually fix the problem on the floor?
Well, instead of handing a forklift driver a confusing paper printout or making them guess, the system provided 3D load visualization.
Okay, 3D visualization. How does that actually look to the guy driving the forklift?
It renders a step-by-step 3D graphical diagram right onto their warehouse management system terminals.
So right on the screen, mounted to the forklift.
Exactly. The loader looks at the screen and sees exactly where the next pallet goes. And the software has already calculated the dimensions, the stackability rules, and that complex axle weight calculus we talked about.
That's doing the physics homework for them.
It completely removes that tribal knowledge from the equation. The source detailed this one technique it uses called pinwheeling, which is notoriously hard for humans to calculate on the fly.
Oh yeah, the pinwheel example. Here's where it gets really interesting to me. I want to make sure I'm visualizing this right, because spatial logistics is tricky.
Go ahead.
So imagine you have a product that slightly overhangs the wooden pallet. It makes the whole thing just a tiny bit wider. If you try to load those side by side into an older, narrower trailer, they'll crush each other, right?
Right, they physically won't fit straight in.
So a human loader relying on tribal knowledge would probably just leave one pallet out, wasting space.
Yeah.
But the Provision S system visually adapts it. It tells the loader to turn one pallet sideways, kind of in a pinwheel configuration, so the different dimensions interlock perfectly.
Like a puzzle.
Yeah. It's like having a blindfolded Tetris player suddenly take off the blindfold and use an algorithm to win the game.
Tetris is a great way to think about it, but, you know, the real world is a lot messier than a video game.
That's true. What happens if the loader is following this perfect 3D diagram and they accidentally smash their forklift into a pallet of paper towels?
Right, or what if the inventory count was wrong and the product isn't even on the shelf?
The perfect digital plan hits a brick wall of 3D reality again, and the planner isn't there to fix the puzzle.
This is where Provision A's load optimization flexibility kicks in. The system adjusts dynamically.
How fast?
Real time. If a product is damaged, the driver inputs the error into the terminal. The software instantly recalculates the entire remaining load and suggests a substitute product from available inventory that matches the required dimensions and weight.
Oh, wow. So the truck still leaves totally full, perfectly balanced, and the loader never has to call the planner in a panic.
The workflow just continues, but, you know, we really have to address the human element here, too.
Yeah, the culture piece. Because you can't just put a screen on a forklift and tell a 20-year veteran dock worker to stop trusting their gut, right?
Exactly. Changing warehouse culture is notoriously brutal. They knew they couldn't just mandate the technology. They had to rebuild the relationship between the office and the dock. So they implemented cross-training.
They forced the two worlds to collide on purpose.
They did. They made the load planners leave their offices and spend days on the dock. They had to experience the heat, the noise, the angry truck drivers.
That must have been an eye-opener.
Yeah.
And the loaders had to do the same, right? Shadowing the planners.
Yes. The loaders had to understand the financial impact of underloading a truck. They learned about customer service metrics, budgets, why that extra 5,000 pounds actually matters to the bottom line.
Empathy is great, but empathy alone doesn't usually change corporate behavior permanently. How do they make it stick?
They changed the scorecard. They instituted shared key performance indicators, or KPIs.
Shared metrics.
Before Project Max Load, the planner was graded on how fast they made a plan, and the loader was graded on how fast the truck left the dock.
Totally disconnected.
Right. Under the new system, they were both graded on the max load success rate. Suddenly, they aren't adversaries anymore. If a plan is flawed, the loader wants to tell the planner instead of just ignoring it. They actually talk to each other.
Okay, so we've got the accurate tape measure data, the Provision I 3D visual algorithms handling the physics, dynamic substitution, and cultural alignment. It's a huge operational overhaul. But did it actually move the needle financially?
The hard numbers are incredible. Across their entire network, the company achieved an 8% increase in payload.
So they essentially found 8% more space inside the exact same fleet of trucks.
Exactly. And by using that wasted space, they removed 4 full trucks per week from their schedule.
Just totally evaporating 4 cross-country trips every single week.
Which translates directly to $22,000 saved every single week in transportation costs.
Over $1 million a year, just by packing the trailers correctly.
And beyond the money, there's a massive environmental payoff here.
Yes, the source talked about a big reduction in Scope 3 CO2 emissions. Is that just a happy accident or a strategic advantage?
It's the ultimate dual mandate. Scope 3 emissions, which are the indirect emissions in your value chain, like outsourced trucks, they are the hardest to reduce. Because the shipper doesn't own the trucks. They can't force the carrier to buy electric
Right,
vehicles.
they control the freight but not the exhaust pipe.
But by utilizing all the space and weight limits, this shipper got an 8% reduction in Scope 3 CO2 emissions per ton mile. Reducing emissions isn't just about waiting for a magical fleet of electric semi-trucks. It's about not sending empty air down the highway today.
Because the most environmentally friendly truck is the one that never makes the trip at all.
Exactly. Empty air is one of the biggest polluters in the supply chain. Every truck you take off the road is a tangible win for the planet and the bottom line.
It really transforms transportation from this back office headache into a boardroom level strategy. So for you, the listener, turning planning execution alignment into a strategic advantage protects your capacity, lowers your costs, and helps the planet, no matter what the economy is doing.
Absolutely. Maximizing payload gives you control over your own destiny.
Let's bring this all home. We started out looking down at a highway overpass, confronted by that staggering reality that 91% of trucks are underloaded, just transporting empty air. We unpacked the causes, software ignoring physics, axle weight limits acting like seesaws, and the bitter culture clash between planners and loaders.
And we saw how the case study shipper reversed it. They went back to basics with tape measures to fix their master data, deployed provisionized 3D load visualization to kill the guesswork, and aligned everyone with shared goals.
Resulting in 4 fewer trucks a week, over $1 million in savings, and a huge drop in emissions. It's truly a masterclass in operational alignment.
You know, I want to leave everyone listening with a final lingering thought to ponder.
Go for it.
We've seen how bridging the gap between 2D spreadsheets and 3D physical reality can revolutionize a shipping dock. It makes you wonder, what other critical areas of your daily operations are you currently managing with flat, outdated data, completely blind to the physical constraints of the real world?
That is a question that requires a very hard look in the mirror. You might think your software is giving you a perfect picture, but you might just be looking at a smudge on the lens. Thank you for joining us on this deep dive into the warehouse reality check. Keep questioning those spreadsheets, and we'll catch you next time.